Motor learning control is an important and rapidly expanding discipline. It is the study of how motor skills are acquired and developed, and is important in rehabilitation and performance. This video will cover the history, some theories and models, and the future uses of motor learning and control.
Motor learning and control really just became a research area in the 70s, though there was research done similar to what we consider motor learning and control research. So a psychologist named Franklin Henry was doing a lot of motor learning research. And in that motor learning research, it was considered part of psychology because it's like controlled by the brain, etc. So he was really interested in how humans acquire and control skilled movement. So he was writing a lot of research about findings about pre-processing and etc. And he wrote a seminal paper saying, I think it was published in 71 or 72, saying we need to move away from psychology, move away from physiology, move away from like other tangential areas and create a kinesiology. He suggested using the term kinesiology and create a more scientific society where we do our own research. We have our own societies like the North American Society for the Study of Sports Psychology and all different kinds of cognition. So he actually created that society. So his work, and he was a instructor at Berkeley, and Dr. Schmidt, who is at UCLA and has a bunch of theories out there, was his student. So Franklin Henry pretty much consolidated the area that we now know as motor learning and motor control, and through many papers saying we need to do our own research and be more scientific and get into human factors, not just mental factors or whatever.
The first model is simple and choice reaction time. Simple reaction time has only one choice and a quick response time. While choice has many choices, is a longer reaction time, and the more choices available, the longer reaction time. Next is the Fitts and Posner learning model. The first stage is the cognitive stage, where there are many errors and gross movements. The next is the associative stage. There are less errors and the person gets slowly better at the skill. The final stage is the autonomous stage, where there are few or no errors and the person does not need to pay attention to the task because their movements are autonomous. Next is discrete versus continuous skills. First we have a discrete skill, where there is a clear beginning and end to the task, versus a continuous skill where there is no clear beginning and end, such as a person jogging by. Next is open or closed environments. An open environment is where there are environmental factors to consider, such as another person to rally with or going against a defender in basketball. In a closed environment, there are no environmental factors, such as shooting a free throw alone. Next, we have fine versus gross skills. A fine motor skill uses very small muscle groups, while a gross motor skill will utilize many muscle groups and use large ones.
Motor learning and control is just expanding and expanding. I think there's so much that they're doing with robotics, and they're like spinal gate generators. There's just so much technology, gaining of technology, and recreating motor patterns from injured people. So that is a really big area, and like they can put these little generators in the spine that will do the same thing as a gait generator, that will create gait patterns in animals, in four-legged animals. So they're, hoping that they can do that in humans. Hasn't worked out in humans. But there's a lot of those kinds of things going on.
Motor learning and control is also important in human-to-machine interfaces. The smartphones and tablets you see today use this technology, and it becomes improved every day.